Welcome to the 23rd part of our interview series. Stephen, you've mentioned the idea of creating a focused electromagnetic pulse using a loop antenna. Can you explain the techniques that can be used to achieve this and the potential challenges involved?
Certainly, Joanna. Creating a focused electromagnetic pulse involves modifying the standard loop antenna design to direct the radiated energy in a specific direction. There are several techniques that can be applied to achieve this, each with its own set of challenges and considerations. Ruth and Brian can elaborate on these techniques.
Ruth and Brian, can you break down the techniques for creating a focused electromagnetic pulse?
Of course. Here are the primary techniques. Dielectric lens. Description: a dielectric lens placed in front of the loop antenna can help focus the electromagnetic pulse. The dielectric constant of the material determines how much the wavefront gets bent, leading to a more focused beam. Challenges: selecting the appropriate dielectric material and shaping the lens correctly are critical for achieving the desired focusing effect. Additionally, the lens adds bulk and weight to the antenna system. Parabolic reflector. Description: a parabolic reflector attached behind the loop antenna can redirect the radiated electromagnetic energy towards a single point, creating a focused beam. Challenges: the size and precision of the parabolic reflector are important for effective focusing. This configuration also increases the overall size of the antenna assembly. Yagi-Yuta array. Description: configuring multiple loop antennas in a Yagi-Yuta array can help create a more focused electromagnetic pulse. The driven element acts as the main radiation source, while directors and reflectors manipulate the radiated energy to travel in a preferred direction. Challenges: designing and optimizing the positions and orientations of the directors and reflectors require careful calculations. The complexity and size of the antenna system increase with this configuration.
What considerations are important when designing a focused electromagnetic pulse?
When designing a focused electromagnetic pulse, several key considerations must be addressed. Optimal placement and orientation. Calculations and simulations: determining the optimal placement, size, and orientation of additional components requires precise calculations and simulations to achieve the desired focusing effect. Practicality: balancing the need for a focused pulse with the practical limitations of size and portability is crucial. Safety and compliance. Regulatory standards: ensuring the device complies with local electromagnetic exposure limits and safety standards is essential. Ethical use: ethical considerations should guide the use of such a device to prevent misuse and harm to others.
To further understand the technical aspects and challenges of creating a focused electromagnetic pulse, we consulted an expert in antenna design and electromagnetic engineering. Ruth, can you summarize the expert's insights?
Stephen's exploration of techniques to create a focused electromagnetic pulse is well-founded. Each method: dielectric lenses, parabolic reflectors, and Yagi-Yuta arrays, offers viable paths to achieving a focused beam. However, careful design, precise calculations, and thorough simulations are essential to optimize these configurations. Safety and regulatory compliance must also be prioritized to ensure responsible use.
Stephen, your detailed understanding of these advanced antenna techniques is impressive. How do you plan to address the challenges and ensure the responsible use of such a device?
Addressing these challenges requires a meticulous approach. I plan to prioritize accurate design and simulations to optimize the antenna configuration. Ensuring compliance with safety standards and ethical considerations is paramount to prevent misuse and potential harm.
Your commitment to responsible experimentation and ethical considerations is commendable. Sharing your insights and strategies not only helps you but also provides valuable guidance to others interested in exploring similar technologies.
In this 23rd part of our series, we've explored the techniques and challenges involved in creating a focused electromagnetic pulse using a loop antenna. Stay tuned for the next part, where we will continue to explore potential defensive strategies and support systems for those affected by similar forms of harassment.
Stephen's story continues to highlight the relentless nature of technological harassment and the sophisticated strategies required to combat it. By continuing this series, we aim to provide a comprehensive understanding and foster a dialogue that can lead to meaningful change.